focuses on matrices. And to start, we're going to answer the question, what is a matrix? And then we're going to talk about how matrices behave and what we can do with them. So what is a matrix? Well, these objects here on the screen are examples of matrices. There are 3 examples here. Example 1, example 2, and example 3. And these are 3 different matrices which have different properties and different things inside them. So what is a matrix? One answer is that it's just a table that contains numbers. That table has to be rectangular, and there can't be any blank spots. So for example, you'll see here we have a 0. We didn't just leave an empty space. Now, matrices come in different shapes and sizes, as you can probably see here. Example number 1 is a 2 by 3 matrix. And what do I mean by 2 by 3? Well, 2 is the number of rows this matrix has, and 3 is the number of columns that it has. And so this is how we refer to matrices. We talk about them in terms of their size. Example 1 is a 2 by 3 matrix. Example 2 is different. Example 2 has 3 rows and 2 columns. So that would make example 2 be a 3 by 2 matrix. And you can see visually the difference in appearance. Example 1 is sort of long and wide. Example 2 is tall and narrow, and that's because they have different numbers of rows and columns. And then example 3 is another matrix. Again, a matrix is just a table with some numbers in it. In the case of example number 3, those numbers are variables, but that's totally fine. We're able to handle that. And example 3 is a 2 by 2 matrix. I'm hoping you can see that there are 2 rows and 2 columns. It's a 2 by 2 matrix. By the way, if the number of rows and columns are the same, we can also just call it a square matrix. So that's a little bit about what a matrix is. Even if we're not sure exactly like why we care about these things or what they do, at least maybe we could recognize one if we saw one. Basically what you're looking for are these sort of squarish brackets. Matrices should have those. And inside of them, matrices should have numbers, or at very least variables represented. With matrices, which has to do with how matrices are defined, is that you should be able to recognize where items in the matrix are located. This is nothing too complicated. All I'm really saying is that it's important for you to be able to tell that, for example, this number 2 is in a certain spot that none of the other numbers are in. The number 2 is in the top left corner. In terms of rows and columns, we could say that it is in row 1 and column 1. And the number 2 is the only number in the whole matrix that has that property. Let's consider another position. For example, try to find the element at row 2, column 3. What number is there? I'm going to circle it in about 5 seconds. The element in row 2, column 3 is this number 10. And it's not super important. Nothing about this is terribly important, other than just that you can identify where numbers are in the matrix relative to others. Okay, so why do we care so much about the position of elements? Well, it has to do with one of the things that we can do with matrices. One of the first things that folks learn about matrices is how to add them and subtract them, and that's what we're going to practice right now. You can see I have 2 different matrices here, 1 and 2, and we are going to add them together to get, well, a third matrix. When you add 2 matrices, the result is another matrix. So now let's talk about how exactly to add these things together. We need to do it position by position. So really, all we have to do here is a bunch of individual little addition problems, and then we have to format them all in the right way. Here's what I mean. To figure out what goes into this matrix's first position there, We need to add up the two things that are in the corresponding positions in the two matrices that are being summed together. So to figure out what goes here, I'm going to add up a 2 with a 4, because as you can see, 2 and 4 are the numbers that are in the same location as this little gap here that we're going to work with. So 2 plus 4 is 6, and therefore, what I'm going to write is a 6 in that position. Again, that is the first row and the first column. Let's take a look at another position. Suppose we want to next fill in the second row, first column. In other words, what goes here? The thing that goes there is what we obtain by adding the things that are in the same position in the two matrices that are being summed. So what is located in that position? Well, in the first matrix, we have a 4, and then we have a -1. What is 4 plus -1? That's our question. And the answer is 3. And so we'll write a 3 there. And we're going to keep going this way. What goes right there? I take the bottom left two elements, -1 and 0. I add those together, and I get -1. Let's work on the second column now. What's going to go here in the first row, second column? Maybe you can see that we're going to add this 1 with that 2, and we're going to get 3. And perhaps you can also see that to fill in the very middle section right there, we need to take the middle number from the left matrix and the middle number from the second matrix there, add those together. 0 plus -2 is -2, and that's what I write. Continuing along, we should have an 8 in the third row, second column. And then in the first row, third column, there should be a 9, another 9 down there in the second row, third column. And then in the bottom right, -2 plus 1 is going to give us -1 altogether. That's what matrix addition looks like. The way to describe it is you do things position by position. In other words, if you're adding, all you need to do is add each position in the matrix to the left to its corresponding position in the matrix to the right to obtain. What we just covered is also still going to apply for subtraction. You can see here I have two matrices, and we're going to subtract the matrix on the right out of the matrix on the left and see what we get. And this process is also going to occur based on the position of entries. So let's work on our first position. What are we going to subtract from 2? Well, the instructions say we're going to subtract 4 out of 2. What is 2 minus 4? 2 minus 4 is -2, and that's what we write in the top left, because of course that's where the 2 and the 4 were. Continuing along, 1 minus -6 is going to be 7. Don't forget, we're subtracting whatever is in the matrix, and subtracting a negative number is just like adding. Continuing on, 3 minus 2 is going to be 1, and 0 minus 1 is going to be -1. Now, one interesting thing about matrices is that, as we've already seen, they come in different shapes and sizes. And so far, we've done an example of addition with 3 by 3 matrices, and we've done an example of subtraction with 2 by 2 matrices. Now, even if your matrices are not square, this will all still work in the same way. If you have a 2 by 3 matrix and you want to add another 2 by 3 matrix, you'll just do it position by position, just like we've done in these two examples here. However, one thing that is worth pointing out, and is kind of interesting, is that there are some matrices which you just simply can't add together. And the deal basically is, if you're going to be able to add or subtract two matrices, they have to be the exact same shape and size. In other words, here are some examples of problems that don't work. These are impossible problems that have no answer. You cannot take, for example, a 1 by 2 matrix and add it to a 2 by 1 matrix. Hopefully I said that right. You can't take a 1 by 2 matrix and add it to a 2 by 1 matrix because they're just not the right shape. You'll see if we try and do this, like this element is in the rightmost position. There is no rightmost position in the differently shaped matrix, and so there's just not a way to do this problem. Basically, matrices have to be the same shape and size.